Graphs are an important part of statistical analysis because they let us view our data, which can then help us interpret the result of our analysis. There are three types of graphs that we use on a regular basis in statistics. The first is the histogram, which is a graph of a frequency distribution in which the bar heights correspond to class frequencies and the bar widths represent class boundaries. To construct a histogram, we must first find the class boundaries. These boundaries make sure there is no gaps between the class limits. If you take a look at this frequency distribution, you notice that between the first and the second class, there is a fair amount of values that could be included here, such as 40.3, for example. Let me show you how we calculate the boundaries. The first thing to do is to determine the lowest decimal place in your class values. In this case, our lowest decimal place is the unit. Divide that decimal place by 2. 1 divided by 2 is equal to 0.5. Subtract that result to the lowest limit. 38 minus 0.5 gives us 37.5. And add the result you had in step number 2 to the highest limit. 40 plus 0.5 is equal to 40.5. Now, what would we have done if our class limits would have been 38.5 to 40.5? Our lowest decimal place in our class limits is the 10th. Divide a 10th by 2, which gives us 0.05. Subtract 0.05 from the lower limit, gives us 38.45. Add 0.05 to the highest limit gives us 40.55. And of course you must repeat that for all of the classes. This is the frequency distribution that actually has the boundaries written down. Now that we have the boundaries, we can build our histogram. First, we must draw the x-axis, which is the horizontal axis, and then the y-axis, which is the vertical axis. Make sure they are always labeled, including units when it's adequate. Then, we add the scales for the frequencies and the class boundaries. Finally, we draw the bars using the frequencies for our heights. The second graph we often use is the frequency polygon. This is a graph that displays the data by using lines that connect points plotted for the frequencies at the midpoints of the classes. Again, the frequencies are represented by the heights of the points. Notice, like here, that we can superimpose the frequency polygon on top of the histogram. But before drawing our frequency polygon, we must first find the class midpoints. To find the midpoints, there are a few simple steps to do. Now remember that our first class goes from 38 to 40, and our boundaries are from 37.5 to 40.5. Step number 1 is to add together the lower and the higher boundary. 37.5 plus 40.5 gives us 78. Then you divide that result by 2. 78 divided by 2 is equal to 39. Repeat for all classes. Here is our frequency distribution with the midpoints for each of the classes. Now to draw the frequency polygon, again we first draw and label our axis. Then we plot the midpoint values with the frequencies. We then connect each midpoint with a line. Just as a reminder, here are the bars from the histogram we just drew. Notice how our points line up perfectly with the middle of the bars. The last graph we will see is the ogive. This type of graph represents the cumulative frequencies for the classes in a frequency distribution. Remember that to do a cumulative frequency, you must add the frequency in each class to the total of the frequencies of the classes preceding that class. Now, class number 1 has no preceding classes. As such, it has no frequencies before that. So it's 0 plus 2 gives us a cumulative frequency of 2. Class number 2 is preceded by class number 1. Class number 1 has a frequency of 2, so you add 2 to the frequency of class number 2, giving us a cumulative frequency of 14. Class number 3 is preceded by classes 1 and 2, who have a cumulative frequency of 14. So we add to 14 the frequency of class number 3. 14 plus 13 gives us 27. And you continue down the row until you get to the end. 27 plus 16 gives us 43. 43 plus 2 gives us 45. 45 plus 1, 46, plus 1, 47. Now that we have our cumulative frequencies, we can build our ogive graph. Like the other graphs, we start by building our axes, labeling them, and then adding the scales. Once we have that, we can plot each cumulative frequency to the midpoints of the class limits, like this. Then, you connect each of the points with a curve. We can draw a lot of interesting information from the simple shapes of our graphs. Here are some of the most common distribution shapes. It's important to note that distributions are rarely perfectly shaped, so we are looking for general patterns, not ideals. Let's look at some of these in a bit more detail. The first distribution shape is the bell-shaped. Notice that this distribution has only one peak in the middle and that the distribution tapers away equally on both sides. The ideal bell shape is perfectly symmetrical. The uniform distribution is rather flat. Of course, some values can have slightly higher or lower frequencies, but notice how much even it is compared to the bell-shaped distribution we have just seen. The right-skewed distribution, or positively skewed distribution, has most frequencies clustered to the left-hand side of the graph and tapers away on the right. The left-skewed distribution is of course the opposite of the right-skewed distribution. We will discuss skewness later in the semester. Now, all of the graphs you've just been shown have only one peak. As such, they are said to be unimodal. When a graph has two or more peaks, like this one, it is said to be bimodal. There are many more shapes of distributions, but these are the most common ones. In the next video, we'll start discussing how we can quantify these distributions.